1966 Sears portable black and white television repair part 3. In part 2 we replaced all the electrolytic capacitors and then had this kind of low fidelity picture that wouldn't stop rolling. And basically right at the end of the video, which was over an hour long, I discovered through doing some voltage measurements that this IF can right here is totally open. And that little tiny, these are little tiny itty bitty IF cans. And so in this video, it's this one right here, it's totally open. The coils are. And so in this video, what I want to do is I want to put the detector diode section back together and put the can back over the top of the detector diode. And then I want to hook the alignment generator up to this, put the TV back together, get it working the way it was, the low fidelity, crappy way it was working, and then hook the signal generator up to it, or the alignment sweep generator up to it, and actually take a look at the alignment and see what it looks like. I think it'd be interesting to benchmark it. The odds of getting that IF transformer are practically zero, and it's been suggested, and I agree, let's take it apart and see if I can fix it. This is not like a bigger IF transformer, so it's very possible that it's going to be so microscopic I just can't see it or work on it, or it might have glue in it, who knows. Also, a quick note, I accidentally deleted some very good comments off the last video. It was accidental. If I deleted your comment, I'm sorry. I was doing too many things at once and my finger slipped. So YouTube does not put stuff in a trash can and then allow you to bring it back out. If you accidentally hit delete, it's gone forever. So if I deleted your comment, I apologize. Post it on this one, because there were some really good comments about the IF cans, and I was trying to copy and paste and save them so that I could reference them in this video. And well, alright, let's get it back together and get the sweep generator on it. And this is one of the prime reasons, this is a prime example of why I totally shun bulk recapping. Look at the amount of time I wasted on this. Yeah, all the capacitors were probably only about $20, but the amount of time I wasted doing a bulk recap on this to find out there was an unobtainable IF transformer that's open, and if I can't fix it, it's, yeah, I guess I could feed the composite video into it, but the goal of the video, the objective here, is to make the thing work right again and not just, you know, botch it because I can't fix it. Yeah, the whole thing is frivolous, right? Who's going to use a TV when there's no analog? But the goal is to make it work right. And if I can't do that, then all these capacitors were just, and my time was sacrificed for just to prove a point, which the point I already know is that bulk recapping is usually a pretty stupid thing to do. The detector can is back on. I've actually mounted the board back in with a couple screws just to make sure if there's any kind of grounding, it's there. We have 3 test points to hook the sweep generator for the alignment. This right here is the detector output. This is where we get the composite video signal out of, fed back into the sweep generator. This right here is our IF bias point, our Agc voltage. So we're going to apply some voltage there to simulate it having a real signal. And then up here on the tuner, this little guy right here is our sweep injection point. This little, it's a test point right here. So those are our 3 test points, and it's pretty nice of Toshiba to make those so easily accessible. So let's pop the sweep generator on it with the bad IF transformer and actually see what the sweep looks like for reference.
You'll get 25 megabits per second plus built-in Wi-Fi, and there's no hard data limits. So wherever you live, now you can do more of everything you love online. Connect on social media, stay informed, watch the latest videos, and help your kids get ahead. No wonder HughesNet is America's #1 choice for satellite internet.
Act now to save big with our limited time offer. Get free standard installation by calling right now.
So that's on
Get HughesNet
local.
To order, call 1-800-747-4610. Be sure to ask about our home phone service too. Call 1-800-747-4610 today.
That's on DX. Oh, crap, copyright material. Here we go. This is more of my style right here. Stool consistency.
Is to transfer proper elimination and restore for better gut health, to help you feel better and slimmer on the inside, all with more energy and vitality. Most people can start to see and feel the difference in about 10 days.
Waking up not being bloated at all, it's made me a happier and more energetic person, that's for sure. Now that's
Interesting that the IF could cause that, isn't it?
my energy is just kicked into high drive.
I have a lot more energy and it's a lot more enjoyable.
After the first 10 days of taking Dr. Ho's cleanse, I became more regular. I didn't feel as bloated and gassy. I was starting to remember names and addresses and phone numbers faster. My energy levels are way back up again. I highly recommend Dr. Ho's cleanse. I feel fantastic. Dr. Ho's cleanse is the fast and easy way to detox your body, reboot your elimination, and transform your health. When we come back, Dr. Ho has some more demonstrations for us. You are going to be amazed at what Dr. Ho has to reveal. But first, don't wait a moment longer. Feel renewed, energized, healthy, cleaner, and lighter on the inside by using Dr. Ho's cleanse.
Now it's time to go with Dr. Ho. Do you feel sluggish, heavy, and slow? Then you may have a toxic gut. You could be carrying around as much as 10 pounds of toxic waste, making you feel heavy, bloated, and sick. And if you don't go every day, your toxic gut could grow. Until now you can go with Dr. Ho. Dr. Ho's cleanse can help purify your system, promote better health and wellness, and help flush that toxic waste out of your body.
That's right. Just let Dr. Ho cleanse your booty hole.
The right tool can make. And the Works GT Revolution has so many new and exciting features you're going to love.
This is your last chance to order.
So I have the BK Precision 415 solid state sweep marker generator hooked up to the set. And I have the IF hooked up. And you can see I'm going to unplug. So that's what we get if I unplug the IF control from the marker generator. And here I can control the IF. So of course that's making turning the gain down, that's turning the gain up, until it, and this is why in the first video, or the second video, I thought we had an AGC control problem. Well, the reason why I think we have an AGC control problem is because the transformer's open and it's not developing the right voltage. So anyway, yeah, this is the marker generator, and this is the AGC adjustment. So I got it hooked up to the scope. Let's give it a signal and see what happens.
And the head adjusts a full 90 degrees.
Guess I can kill that. Let's see. Oh. Stand by. What am I doing wrong? I've been playing with this for a few minutes and I've got it set up pretty accurately. It just takes some time kind of going between the AGC voltage and all that. And Here are the 4 markers that I have turned on. And here's what it looks like. I hope this is showing up okay, but you can see this should come up and then be flat or be semi-round at the top and come down. This whole section of information, this marker right here and this marker right here should be at the top of the 2 peaks. So all this information right here is just missing. And that's probably, so instead of this dip right here, this should come up and then go across. So all of this right here is all missing information. You see what I mean? This is what it should look like. It shouldn't come up and then dip down and then come over here, because that's just all missing information. That's why the picture is so low fidelity. I'll try and hold this steady, but this is adjusting the Agc voltage. And they just say adjust it to a point to where it's not overloading. Well, you can see there it starts to overload, and then that just kills it. So anywhere here is kind of not overloading, but irregardless, you can still see that big dip there in the middle of it. That's where the bad IF transformer is. This is the defective transformer that's open. It's not really a transformer, it's more of a peaking coil, I don't know, tuning coil, and all 3, it's just totally open. Nothing's connected to anything. And here it is right here, this one. It's a Toshiba part, TRF719E. And if we look at the bottom, so this is the pin that's grounded and these are the other 2. Guess these are just open. I don't know, I'm going to pull it off here. I know my abilities pretty well, and I give myself about a 2% chance of fixing this thing. This stuff is just so tiny, and the wire is just microscopic. It's like thinner than a hair. Can you see that? You can see, let me see how close I can get in on this. You can see where the 2 wires wrap around the pin on the left. That's ground. Let me get the big magnifying glass. I'm trying to hold it steady. I know it's bouncy as hell. Okay, you can see right there where the 2 wires wrap around, and then over here it looks good. So it all looks good from the bottom, and of course there's the capacitor right there, that little round thing. So the wires are not broken here on the bottom. Bummer. Okay, here it is on the inside. You can even see the wires there. Let's continue trying to take it apart. And check this out. Diagnosis has been completed. Somebody at some point tweaked this. Let me get a tripod. Okay, so here's what happened. Somebody at some point was screwing with the alignment on this. And I don't know if it'll show down in there, but the core is broken on top. And I noticed that the core was driven all the way through. What they did is this bobbin here, where the coils are wrapped around, that will rotate. What they did, you can see the broken wire right there. What they did is they cranked the core down so hard they rotated the bobbin and broke the wires, destroying the transformer. You can see another broken wire. So yeah, that bobbin right there will rotate if you crank the core down too far. Let me look at this. Let me see if I can fix this. I mean, look at that right there. Geez. You just need patience on a level of I don't know what to deal with that. Okay, so here's our problem with this. We got 2 spools, and we got down at the bottom we have 4 wires. I hope it's focused, but there's 2 wires here. And I'm doing this mainly for my documentation, and I hope it's in focus. So we got 2 wires here, and we got 1 wire here and here, but we only got 3 wires, so I don't know where the 4th wire went. If it's a center tapped coil, it should have 4 wires that are broken. So I'm on the second bobbin down from the top, the second roll, and I'm going to assume that that was connected to the center pin. So what I'm going to do here, I cannot believe, oh, that just broke off like, oh, look at this, it's just breaking off like, oh crap, man. You know what? Can't really do this with the camera in the way. Wow. Okay, so I took one, looking at it from the top, I took 1 clockwise rotation off the second bobbin down. This one, which I have no idea where this one was connected. I hope it's showing up here. I'm going to take 1 rotation, 2 rotations, 3 rotations. I'm going counterclockwise. And that was that piece of wire. So, ooh, cuckoo boobler, digoogon, googaloogle noobler. Geez, so what did I just do there? I took from the center pin up 1 rotation around, the second one down, and then it went up and it went 2 rotations around the first one. Because I unrolled it twice. So center up to the second roll, 1 rotation, up to the first roll, 2 rotations. Okay, let's see what else we got here. The good part is underneath the broken off part. Alright, stand by. So here's a roll of wire, magnet wire, and I have several rolls of this stuff and I can't find it right at the moment. Of course, my stress level is up pretty high right now trying to rewind this thing. I think this is actually a little bit smaller than what was originally on the transformer, but I don't care. Thickness of wire should not affect anything. It's number of turns, and I cannot find the end to this on here. I don't know where it is. Get it in the frame, and I can't find the other end. It's broken in the bobbin somewhere. It's always entertaining when people contact me. Oh, will you fix my vintage TV? Do you think you could pay me to do this type of work? Like, really? You know, I mean, parts just aren't available. That's why these TVs get condemned and were condemned back in the day. And, you know, if you want a vintage TV, this is a labor of love, or maybe a labor of insanity and mental disorder. You know, you got to do it yourself. And you see this stuff, and yeah, this is cuckoo deluxe. This is like rubber room level I'm about ready to go in the house and pop a Seresto. Okay, so there it is. It was broken off down inside there. Yeah, it looks like the turns on this one are going this way, where the turns on the other one were going the other way. I think. Okay, according to my notes, this is right, but I don't know what lead was connected to what pin. I'm just kind of guessing, and I'm looking at the SAMs. The SAM shows basically a small coil and a big coil, and you can see here how this bobbin, I'm sure this is not in focus, but how this bobbin will rotate on the base. And so I gotta try and move that core. The core is broken, like the top of it's chipped off. Someone really was abusing this. Alright, here's the next problem. Every single one of these cores is broken. That one is narfed up really bad. This one's pretty bad. This one is cracked so bad I can't even turn it. These three look okay. Someone was in here trying to align it without the proper tools or knowledge. If you know, if the damn thing works, don't get in here and tweak these coils. Unless you have the proper equipment and know what you're doing, don't tweak this crap. I mean, these are all jacked up, and I measured, the coil's not open on this one, but if I try and turn that core, the bobbin starts turning, so it will rip the wires apart. So I don't know where I'd find cores for these. I guess I could look, but I think the cores are kind of, I don't think they're generic. Check this out. This is, I believe this is NEC. Was this out of an NEC or Hitachi TV? This looks like it's from 76. There's a previous video on this, I think me drop kicking it or something like that. Anyway, I might be able to Klinko snorfulate these cores out of here. But I think what I'm going to do is let me pop the transformer back in and let's take a look at the alignment. I got the core kind of in there where it looks like it originally was from the factory. They put glue on top of them so you can't get them out the top. It looks a little bit different, but we still got this massive gaping hole in the middle. Need to be able to adjust that core. 2 hours later, I finally got all these cores loose and turning. I had to break a couple of the cores out. I took them out of this old radio board. Oh, what a mess this thing is. Alright, this is with all the cores. I'm going to try and align it now. I still got this big hole in the middle here. I don't know what that's about. If I can... dim on the scope, but bright in the screen. Alright, I'll just go here. You know, and you can't take anything for granted on this that it hasn't been tweaked. Okay, that's got to be one of the traps. See how it's moving? Let's try the other trap. Ooh. There we go. That's what we're looking for right there. See, now See, now we got our nice fat bandpass there. And that was one of the very first alignment points. Okay, that's the first IF transformer. Let's turn our 44 megahertz on. This should be right in the middle, which it is. It's the Agc voltage. Second IF transformer. The third IF transformer. This is the fourth IF transformer. This is the coil that I rewound. Doesn't seem to do much of anything. This is the coil next to it I replaced. Ooh, look at that. That corco-twerculates the tilt. What happens if we... kind of really... That's kind of really hitting it hard right there. I don't know if the one I repaired is right or not. So you can kind of actually flatten the top off there. I'd like to shift the whole thing over to the right a little bit. Yeah, like that. There we go. You just got to work with it. I'd like the slope on the left to be a little bit more a little bit broader, a little bit more straight. Isn't this boring? Isn't this about as much fun as watching golf? So I just wonder how the gain is. I wonder if it's, you know, going to be deaf. See, as I turn it down, I kind of get a slope there, so I want to kind of tweak it so it's kind of tweak it so it's uniform as you give it more power. It's gonna tilt a little bit, but you want it to. What I'm doing is I'm adjusting the power on the 415. We need to widen it up a little bit. Alright, let me play. I'll be back. I don't know. This looks fairly decent. You know, I don't even know if I got that coil wound right. You know, at least the bandwidth is there now. The band pass, at least it's wide enough. Let's see what the picture looks like.
We're spending a month at my kid's lake house. We don't worry about money anymore. We're having such a nice life.
Thank you for being with us today on Helping America's Seniors.
There's a misconception that when you get a reverse mortgage.
So it's fixed. It's still, that's turning the fine tuning. It's still a little bit, it's a little bit overloaded. I'm trying to understand this local DX thing. I don't really think it's designed to have a converter box driven directly into it. If I go to local, it's a little bit noisy, but
Reverse mortgage was a blessing that provided us the ability so that we could stay home.
We would have had to get to some kind of residential living arrangement.
We love our home and our cats. We love to go out in our yard every day, and to lose that would have been a tragedy.
We would certainly not be able to do most of the things that we do now without this reverse mortgage.
10 years and counting with no mortgage payments. It's great.
Yes, I would certainly do it again.
It was the best thing.
Call the number on your screen right now and speak with
there's still a
reverse
power
mortgage
supply
professional.
issue.
With one call, you can
But that's
reverse
into the,
direction of your life.
that's into the,
Age 62 or over, you owe it to yourself and your loved ones to call the number on your screen now.
that's into the RF. That's through the IF.
From a reverse mortgage, please make sure to give them the toll-free number and then encourage them to call and get more information.
But the best time to call is right now.
Oh, of course it is.
Reverse mortgage professionals available to speak.
Of course
with you
it's the
right
best
now.
time to call.
There'll be no busy signals, and you won't be put on hold.
Them. So why not call right
It in stores, so act right now. To order the Power Air Fryer, call 1-800-828-6925. That's 1-800-828-6925 or order online at powerairfryer.com.
In my opinion, the measure of good fried foods.
Oh, I like this guy. Listen to this guy.
Yeah, I was hoping you would please. Stringy on the
The
inside.
answer to that is yes, 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 and okay. Sorry.
All right, I could have thrown that in a vat of oil, but I didn't.
I'm glad you didn't. It's delicious and it tastes just as good.
But now what we're gonna do is we're gonna take the mozzarella sticks to another level. My version of Denny's fried cheese melt.
Good. Cheese, and a spot of
And
cheese.
then more cheese, just a touch of a button, and this is what you get when you take them out.
Okay.
Oh, I'm sure they use one of those at Denny's. Looks like a
Kidding me?
commercial piece of equipment.
Real cheese, but it's air fried.
Look at this. Are you
That's
kidding?
crazy.
Oh man.
Go
One
for
you.
it. Okay.
All right, one for me. For the first time, I think I got nothing to say.
That's hardcore delicious.
Good talk.
I mean, really.
So what I'm going to do now is I'm going to show you how to to make refrigerator pretzels.
All right.
They're so easy to do.
Oh, like a little pretzel bite.
That's right, I call them that because I use refrigerator dough. This is my favorite part. It's so versatile, and I'm telling you, in the...
Right over there. Has anyone else been here this evening? Anyone called?
Just Enos Waterton. He wanted to make sure you got away all right. I didn't know then you'd missed
Perry Mason, I'm sure that's copyright.
Have you ever had a moment when you thought about taking action and finally doing something about your hair loss and then stopped yourself? Because
Yes.
you're afraid of what other people might think?
Yes.
Why go through life feeling like you're living it on the sidelines?
You know me all too well,
One
Mr.
challenge in
TV.
your life.
Ban this technology. The two cities, which are just north of the heart of Silicon Valley, are looking to ban any city department from using facial recognition and even getting public input before taxpayer dollars are used to buy license plate readers, toll readers, body cams, and biometrics tech. We have to bring in investigative journalist Ben Swan, who has been following this story.
Oh, I like Ben Swan.
More in depth. Thanks for joining us, Ben.
Thanks for having me on, Scotty.
This is a great hypocrisy, but I guess at the same point, I mean, no better person to protect you from it than the person who invented it. This proposal in San Francisco would ban the use of facial recognition as well as any information obtained from this technology. This is a big step, considering how quickly cities across the United States are really starting to use and embrace this facial recognition. Am I correct?
Yeah, you are correct. It's actually a huge step to see this happen. First of all, number one, look, we've been saying this for a long time. The only way you're going to be able to deal with this increasing encroachment of tech companies and tech services around the world is to eventually start to walk back from them. And San Francisco, Oakland, finally looking like they're going to take the first step to doing that. Consider the fact that in New York right now, when there is an incredible net of surveillance cameras being set up, bought, purchased, built up as a surveillance web essentially across the city. That is happening in New York right now. Meanwhile, San Francisco saying, not only can you not use the facial recognition software without further discussion, but we don't want you using that technology at all in police investigations, in private citizens' work. I mean, it's pretty astounding to see this happening. Hopefully it'll pass because I think it would be a good thing for civil liberties.
That's the thing. So if San Francisco were to pass this ordinance, it would be the first of its kind to actually ban the use of facial recognition. What reasons are lawmakers giving for being against this type of technology?
Well, one of the things is this push in San Francisco has actually been pushed by the ACLU, so they've been behind a lot of this. But look, it really comes down to things that you and I have talked about before, which is that facial recognition technology and the software behind it is not very reliable. And despite
God, that power supply regulation is annoying. Where's our air fryer grill here? I can't.
Is people's civil liberties being violated.
It was something that we had in common.
Where's the... Here we
Now
go.
that was a fun dessert, but I have another fun dessert. Have you ever eaten a cactus?
Those are edible?
I'm going to show you how to make little cactus desserts. Air fryer is great for baking desserts
Awesome.
because it's got the convection, but it's sort of like convection on steroids is really what it
Oh
is.
yeah, just bake your houseplants for dinner. Look at this.
And this is what they look like when they come out.
Yeah,
I'm gonna
just
show you
bake your
how to
houseplants in this toxic Chinese air fryer.
The icing right around the top. You want to get every bit of it on there. Now I have crushed graham crackers. You take the upside down,
Wow.
give it a little
I
smash.
get it. Yeah, the dirt, the sand.
That's right. It's like potting soil, right?
So cool.
Then I have a donut hole. Of course, another thing you can get anywhere, right? And a toothpick. I just drop it on top,
Okay.
press it down. Now what I do is I make little pulls.
I need to put the can back on the IF transformer we repaired. Oh, you notice there's no more of that noise in the picture from the audio. No more of the squiggly, quirky, twirblery thingy. I need to put the IF can back on. I need to put the shield back on top of it. And I think I'm going to call it done. You can see here there's absolutely none of that noise in the picture with the audio. Turning the fine tuning. There is still this AC hum, and there's something wrong in this power supply. And it could be one of these germanium transistors in this thing they're calling a filtration, active power filtration. I don't know if that's like an actual regulator type deal, or if that's just some type of canceling circuit. I'm not sure what that's about, but there is none of that noise. The other problem with this is it has a local DX switch on the top, which I've been screwing with, and it's way too sensitive in DX, and it's not quite sensitive enough in local. And it's I mean, I can adjust it on this thing. I can adjust the gain. This is supposed to tell you how good your bandwidth is. How good your definition is. You can see the lines here. You can see the lines here. It's pretty much, these here are pretty much gone. So I don't know if that's good or bad or what that is. I'd have to compare that to another TV, but stupid AC hum bars. And the flickering is just... I should try going into the composite video input on this and see if the definition's any better. So I might as well, hell with it. So we're right here right now. You can kind of see the lines. Okay, that's with the direct composite, and I would say the bandwidth is a little bit better. I can see the lines all the way over to this one with the direct composite. See what I mean? It just overloads. So that's through the IF. And that's composite. IF. Composite. Wow, that's an incredible difference. This thing still ain't 100%. It is so touchy. Yeah, you just ain't getting it through the IF. You ain't getting the... Yeah, I mean, look at the difference. That's direct composite in. The definition just gets so much better. Except that stupid hum bar. Oh, it's usable. It's not bad, but it's not good either. I guess the next thing to do is to look into that power supply issue, but I think I kind of need a break from this thing. I'm about ready to EOL it. Okay, so you know what, to be fair, if you crank the contrast up here, this is on the IF, you can look at the top right here, you can see the defined lines. I could zoom in on that. It definitely is better. Look at the top right here. It definitely is better with the composite. So when I hook composite up to it, I have to turn the contrast down. And yeah, composite does look better, but you know, definitely the very last. So there's a little bit of loss with the IF, but that's probably to be expected. I mean, it's not going to be perfect. You can see as you detune the IF there, you detune the fine tuning, you just totally lose it. I mean, look at that. The definition just goes away. Yeah, if you peak it up on, peak it up there, and then you start to get the noise in there from the audio. So yeah, definitely, but I don't want to do a composite input. I really don't. You know, this is a novelty. This is a repair video, and I'm not, I don't play video games. I've never played video games in my life. I wouldn't even know how to play video games. This is basically just a novelty, you know, maybe hook it up to the converter box once in a while and impress myself with the amount of time I wasted on something so frivolous. Glad it was entertaining, but man, this was a real struggle with this thing. Yeah, this power supply issue's got to get figured out, that's for sure, because this is really, really bad.
Shows that the Golden State is peerless among developed economies for increasing population, expanding gross domestic product, improved joblessness, rising personal income, investment in innovation, and wealth created by its stocks and bonds. So the California GDP, by the way, just to put it in context, is #1 in the United States, and it's 60% larger than #2, which is Texas.
Well, certainly they have Microsoft, they have Apple, they have
Microsoft,
is in Seattle, it's up north.
Yeah.
But Silicon Valley,
They have
clearly.
Facebook, they have
right,
Uber, Lyft, all of these.
These are the biggest, the biggest corporations in the world.
They have all
Apple's
these
the
biggest
VCs and all that stuff. So there's a potent mix.
Yes.
Right. So no doubt that it is a potent mix of output for sure.
Something is happening there with innovation. So we're going to look at drill down into some of the data here. Few of the 34 nations in the Organization for Economic Cooperation and Development come close to California's 3% average annual growth rate for the most recent 5-year period. More than 2.2% for the 50 states and 2.4% average for the 19 countries sharing the euro currency. So this is a chart showing California. The only area really beating them is China. And
well, let me ask you this. So those who argue that the tax rates in California are onerous, it doesn't seem like it's cutting into their growth.
That's what they do mention, is like that people complain that there's so many regulations and taxes and it's going to destroy it. But it doesn't, because such vitality catapulted the largest U.S. state to #5 economy globally last year, behind Germany, Japan, China, and the US. It overtook the UK 2 years after Britain voted to leave the European Union, triggering economic struggles, including a record devaluation of the pound. It's a lot to do with their publicly traded companies out of California, because California's publicly traded companies returned 420%. By comparison, the S&P 500 gained 239%. China's index advanced 57%. Japan's TOPIX climbed by 70%, and Germany's DAX just 121%. So their companies are returning more, and it has a lot to do with their margins. I mean, these are the craziest numbers of this entire article of Bloomberg. California companies turned $100 of sales into $57 of gross profit. They topped the $49 average for the U.S. So in the U.S., you sell $100 worth of goods, $49 is profits. Here, $100, and they get $57 of gross profits. That's versus $35 for China, $39 for Japan and Germany.
Right, that's because when you scale up these companies, it's just a matter of adding one more server to the network, and the enterprise value increases exponentially. So the cost of another server is somewhat, small compared to the growth that you get, the exponential growth, the Metcalfe's law of the value of the network expanding exponentially versus the linear addition of networks of nodes, right? So this is the California effect. Now, in the grocery business, right, to put this into context, their profit margins are 1%. That's a huge part of the economy is the grocery business, and it's a 1% margin. Here you're talking 60-70% margins.
Well, it's also indicating that they have a lot of monopolies there, because only a monopoly could get that sort of profit margin, which is interesting that Warren Buffett loves to invest in monopolies, and yet he was very slow to enter the tech sector. And here they're showing and demonstrating that, 20 years after the dot-com crash, that they've now have we have a different paradigm happening. We have monopolies controlling everything, but they did invest in jobs, increasing its employees by 15%, twice the average for corporate America, almost double China's 8%, more than 7 times Japan's 2%, and almost quadruple Germany's 4%.
Well, it shows you the benefit of having nice weather. Why not surf, get a tan, and build a multi-billion-dollar company while you're on the beach? Well, we're going to take a break. When we come back from our surfing,
haven't reduced expenses as the number of youths in juvenile halls.
Okay, now I'm on the battery.
Grows to trim spending. Officials say it won't be easy. A lot of juvenile halls, prisons for juveniles in California, they have managed to cut the number of children they incarcerate. So some of these juvenile halls are only a third full. However, they still have the same amount of union guards and service around these, and the building costs. So California taxpayers spent an average of $284,700 to keep a child locked up in juvenile hall last year. County-level data from the Board of State and Community Corrections revealed, up from an inflation-adjusted $143,200 in 2011. So this is doubling the cost in just 8 years. But several Bay counties were among those spending the most per child, topped by Santa Clara, where the figures showed an annual cost of $531,400 to detain a youth offender.
Pretty crappy.
no way.
$531,400 for one kid in juvenile hall in Santa Clara.
So some kid steals a candy bar from the 7-Eleven, and we pay $500,000 a year to keep him tied up in a juvenile hall.
Those in the Bay Area, where they're making a lot of money and their property prices are escalating rapidly. But yes, they're paying $531,000. They should just, they're good on profit margins in California. Basically, they should say, "Here, kid, take $300,000, and don't commit any crimes for the next 10 years."
Well, clearly they could, even using the Lori Loughlin metric of what it costs to get into university, could afford the finest university in America with those types of numbers.
Part of the problem is that you have the building costs, so those are fixed. You have to pay these workers, the prison guards, who are mostly unionized. That's why California spends more on prisons now than they do on universities. But perhaps they could divert some of this, put the prison guards in the universities so they spend more on universities than they do on the prisons. But it's pretty decadent.
I'm curious to try substituting this transistor right here that's all rusty. This is the what they call the active power filter, which I don't know, doesn't really look like a regulator. And I was looking for kind of a high current germanium transistor just to temporarily substitute in there. And I came across this in my stash. And these were used in automotive radio, the audio output transistor that drove the speaker. And I was just impressed. You probably never see another new old stock one of these. I was just impressed with the presentation of this. Of course, these are these super high current stud mount. They use these in old car radios, but just look at the presentation of this. It's of course GM, it's General Motors. Made in USA, imagine that. Printed in USA. So you open it up and it shows right there, has a nice little cutout, and then you fold it open and there it is. And in here, see, it's so exciting and cool, the helicopter's coming to check it out. So in here's the mica insulator and the mounting hardware. So isn't that cool? Today you buy a transistor and it comes in a plastic bag. Just the effort that they went through to, you know, present something. It's probably pretty valuable. I could probably get $1,000 each for these on eBay. Check out what the forward drop is on these things. Base to emitter and base to collector. 0.064, 0.065, and generally for germanium it's around 0.2. For silicon it's around 0.6. But yeah, I mean, and they always have this kind of weird leakage, reverse leakage thing too. But yeah, they're good. Oh, this one might not be good. These things just leak.
I don't mind painting brick if you want to paint it brick, but again, what makes me nervous about that question is they're saying what everyone is doing, and we're much more interested in what you think is the best look for your family. Brick can be beautiful, and if that's what you like, leave it.
One more thing, Carl Monroe on Facebook. Jeremiah used to work for Rachel Zoe. What was that experience like? From working for someone else to managing everything yourself?
Oh my God, it was so hard. It was so hard and so awful, but the rest was in the purpose. I sold everything I owned, my car and everything, to buy my LLC.
Okay, that's with the Delco transistor in there. I think I'm going to try a Russian germanium, but yeah, that's not correcting it. Both the hum bar and the audio influencing the picture.
Design, currently airing Saturdays at 9 p.m. Eastern on TLC, and as always, you can find me on Twitter at King's Things. I'll see you next time.
Yeah, Larry King is on RT now.
Opposition leader Juan Guaido was all smiles as he attended a meeting of the National Assembly in Caracas on Tuesday. Opposition members discussed a proposal for Venezuela to return to a regional defense agreement from the Cold War. other nations, like the U.S., political cover to increase their involvement in Venezuela. Also seeking more influence in the country, the International Contact Group on Venezuela has announced that it plans to send representatives to Caracas.
Same thing. That's with the Russian transistor. That little guy right there. P605, I think is what that is. Yeah, so I'm looking at this power supply circuit, and this right here is the transistor I've changed, and it didn't help it. So this is the main line here, and the only place I see this connects is to the audio output. So this has to be some type of primitive regulation here. And with this transistor out completely, the set still works, which would kind of make sense because it's going to pull power. Well, it really shouldn't though, because that would be almost 1,000 ohms. The set was still working with this transistor disconnected, and I don't even see how that's possible, because you have a 500 ohm here and a 400 ohm here, and yeah, it would pull voltage through this, but that's not going to supply enough current. 12 volts or 1,000 ohms is not going to run this thing. So what's going on here? How are we getting... Because I had the base and the emitter disconnected, how the hell are we getting voltage to the rest of the set with this transistor out? I wouldn't be surprised if there wasn't some weird wiring thing that this guy did to this. Now that I look at this, I don't see how that's possible. Something's going on here. Okay, scratch that last clip. You know, I make a lot of mistakes in these videos, and I admit that, and I'm okay with it, because this stuff can be confusing, and I try not to edit it. I just try and keep it real. But, of course, here comes the wind. I just went through and I checked all of these resistors, and they're all good. So this is a very simple circuit. I don't know if it actually regulates, because it doesn't. Usually a regulation circuit will use a Zener diode as a reference or something. So I'm not quite sure what they're doing here. This might just be some noise cancellation or feedback. They use a PNP germanium and an NPN germanium. Of course, the big PNP germanium's up here, which is easy to change. Well, the little driver is down right there, very hard to get to. So I'm tempted just to leave this TV alone. I still think there's something wrong with it, but I don't know. Maybe it's time to just dig into something else, like that little Sony or that Sanyo or that other Toshiba. This thing is just a total nightmare. It's been abused and tinkered with by somebody else who really screwed it up, and this is trying to sort out another man's project. And I had another video with a Motorola TV where someone had put all the wrong transistors in the tuner, and that was just a time vampire too. So when someone else tampers with them, they become a real time vampire. It's better to buy a virgin and ruin it yourself. Continuing on with this beast, because I really don't like to give up. There's kind of one last thing I wanted to check, which was the active noise filter driver transistor, which was on this board here. And yeah, I had to pull the whole thing apart to get to it. And this is this guy right here, 2ST43, which the symbolism indicates that's an NPN germanium. If you look at the voltage drop, there's 0.2 volts voltage drop from base to collector, or base to emitter rather, and 0.1 volt from collector to base. It's a real simple circuit. And I really don't put much stock in these stupid little $10 testy doodly Zeeblers, but check out how this thing tests. Forward voltage drop is 5 millivolts and the gain is 1. This is in a different one. I have 2 of these things. And again, the gain is 1 and the forward voltage drop is 16 millivolts. Am I reading that right? Okay, we're going to try one of these. This is a GT404 NPN Russian germanium. I like the flickering thing there, but anyway. Our numbers are a little bit more realistic on these. So let's pop one of these in there. GT404. NPN germanium's kind of rare. Tacky to the max, yes. Worth a try, yes. Hopefully it gets rid of the stupid AC 60 cycle hum bars in this thing. Nope, it does not appear that it got rid of the 60 cycle hum. You can still see it twerking there. So I don't know what's wrong with this thing. I really don't. I have no clue. What a trip. What a trip. Okay, I'm done this time for real.